So what are square roots? I'm going to show you a quick review on square roots in preparation for your midterm exam. The first thing you have to understand about square roots is what the word square means. And we know that a square has to have equal sides. So if you know one side is 4 centimeters, that means all the sides have to be 4 centimeters. Then, if I asked you what's the area of this square, you would tell me the area is base times height, which is 4 times 4, which is 16 centimeter squares. The square root would be the length of one side of the square. How do you represent square root? You take the area of the square, you put it under this square root symbol, which is pointy. It looks like a long division symbol with a point at the end, and you write 16 underneath. That means you have to find the root of that square, which is the length of what? The length of a side, which is going to be 4. You wouldn't write 4 times 4, you would just write 4. And then you can prove your answer by saying 4 multiplied by itself gets us 16, which is the area of the square. If you understand this, we can move on to the times table. Because squares are made up of equal sides, and to get this, now look, we call the area, whatever the area is, let's say it's 16, like the last example, that 16 is called a perfect square because whole numbers multiply to make it. And if you look at this times table, these are all the perfect squares because 2 times 2, let's say you have a square with 2 and 2 on the sides, you get 4. 3 and 3 makes 9. 4 and 4 makes 16. We call these guys here square numbers. And it's good to memorize the square numbers because once you take the square root of a number, of a square number, let's say 36, you just look up and you say, oh, 6 times 6 is 36. So the answer to square root of 36 is just 6. And you can do the same with 144. You take the square root of this perfect square and you get 12 times 12. So the length of one square side is going to be 12. And that's how you can easily calculate the square root of a number. Now, I can also ask you to square a number. There's a difference between squaring a number, square a number, and square root a number. You have to understand this difference. Square root the number. If I asked you to square 4, what I'm asking you to do is turn 4 into a square. In other words, multiply it by itself. We use that symbol to make 16. This is squaring a number. Square rooting a number would be the opposite. You have to take a square number, any one of these, like 121, and then square root it. You got to put that square root sign, and then you get 11, because 11 times 11 is 121. So squaring a number involves multiplying the number by itself. Square rooting the number means do this. We're going to take square roots of these guys. 49, square root of it becomes 7, because 7 times 7 is 49. You square root this one, you get 8, because 8 times 8 is 64. This one, right, 12. Now 169 you might not know, but you can use your times table, find it right here, and then you look up, you see 13 times 13. That's a square. So that's going to be our square root, 169. This one, if you look on your table, you're going to get what? We're going to get 196. Let's find it. Oh, there it is. 14 times itself. So we're going to write 14 over here. And then the square root of 9 is what? It's going to be 3 because 3 times 3 is 9. Sometimes we don't have the luxury of using these nice, beautiful square numbers. Sometimes we get these ugly numbers like 51, which are not square numbers because they're not in this list. There is nothing, no whole number multiplied by itself will make 51. So we have to estimate and put it on the number line. The strategy is to pick a bigger number, a number bigger than 51. That's a square number. What's bigger than 51 and square? 64 is a square number bigger than 51. And then pick a smaller one, that would be 49, and use them as your reference points. As a what? As a reference point. Watch. You put square root of 64, that equals 8. And the square root of 49 is going to be 7. Now it says estimate, so we just want a nice estimate. The answer is going to be between 7 and 8. What's between 7 and 8? Well, there's a lot of numbers. There's 7.1, 7.2, 7.3, 7.4, 7.5, and so forth. But what is 51 closer to? Is it closer to 49 or 64? It's closer to 49. Now, is it really, 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 really close, or is it just close? I would say it's really, really, really close. It's only 2 numbers away. So we could say something like 7.1, 7.2. I'm going to go 7.2. Okay, and I'm going to use that. Now, putting it on the number line, 7.2 is going to be bigger than 7. So here's 6, here's 7, and these numbers are bigger than 7. 7.5 would be in the middle. Okay, I don't want to put it there. I want to put it around 7.2. I want to put it, it's going to be really close to 7. So I'm going to write square root of 51. Notice I didn't write 7.2. I wrote square root of 51. That shows advanced thinking here. I'm writing square root of 51. And that's the better answer. Some of you might go like this and write 7.2. I might take half a mark off because I want you to plot this square root on the number line. Let's do the next one here. Square root of 92. What's a bigger number than 92? That's square. That would be 100. Smaller, right? 81. 81 makes 9. Square root of 100 makes 10. So it's going to be between 9 and 10, but what is it closer to? Let's see, it's only 8 away from 100, but it is 11 away from 81. So it's closer to the 100 side. So what I'm going to do is I'm going to move this one a little bit closer to it. So my answer is going to be between 9 and 10, but closer to 10. Now, is it super, super duper close, or is it just kind of close? It's actually almost halfway in the middle. It's a little past the half. So we can say something like 9.6 maybe. And then, I got a problem here. Because I have 7, 8, 9, and then I run out of space. So I'm going to change this one here because I made a mistake. I'm going to make this 9. I'm going to make this 8. Let's do that. And we'll put it just past the halfway point and call that square root of 92. This one here, we're going to write, the bigger one is going to be 144. The smaller one's going to be, what's it going to be? Yeah, 100. Oh no, 121. 11 times 11, right? So this makes 11, and this one makes 12, and we need something between 11 and 12. But is it closer to 121 or closer to 144? Yes, it's closer to 144. So you're just going to enjoy life, man. You're going to write it almost 12, but a little bit less. So you're going to say something like 11.8, 11.9, let's say 11.8. Oh, I made another mistake. Let's make this 11. Let's make that 12. And we'll make that 13. Now we're going to write 11.8 is going to be kind of right here. Mr. Melham wrote 11.8. Let's write square root 141 instead. This one here, we're going to pick a bigger one. It's going to be 16. A smaller square number is going to be 9. We know this makes 3. This makes 4. Now pick, what is it closer to? Is it going to be closer to the square root of 9? Or is it going to be closer to square root of 16? Let's see, 9. Count on your fingers. 10, 11, 12. Oh man, it's so close. It's only 3 away. But to 16, it's 4 away. It's almost the same. So it's like almost in the middle. But a little closer to this side here. So we're going to say 3 point what? Here's 3.5. I want a little bit less than 3.5. So we'll put it here. And we'll call this the square root of 12. Now this one's going to be square root of 25, which is 5, and the square root of 16, which is 4, and it's only 4 away from 16, but it's 5 away from 25, right, this number here. So it's almost in the middle. It's almost the same way, but it's a little bit closer to here because it's only 4 away. So we're going to make it about, 4.5 is in the middle, but we want maybe 4.4. It's so close to the middle. So here's the middle, and we're going to put it like right there. And we'll call this the square root of 20. Now here we have to draw a square around all the square numbers. So is 42 a square number? No. How about 49? Yes. So we're going to make 49, and the answer would be 7 and 7. You don't have to do that part. I just did it because I can. How about this? Square root of 64. Is it a square number? Can you put 64 in a square and make a nice square with no decimals? Yes, you can. You get 8 and 8. I'm just showing my work here, guys. I'm just showing my work, baby. I'm just showing you that I'm proving it, that it's a square number. How about 54? No. Actually, it does tell me. It says then find the roots. Okay, so I am doing the right thing. 144, yep, we can put it in a square. That's just 12 and 12. 88, no. 6, yeah, right, 6. 3 and 3. No, can't do that because look, what's 3 and 3? 3 times 3 is 9, not 6. So don't do that. That doesn't work. But 9 works. You're going to get 3 and 3. 15, no. 100, yeah. We're going to write 10 and 10. Mr. Melham, that's not a square. That's a rectangle. Yeah, I know. Just deal with it. It's a square for now. And root 12, well, 12 is not a square number, so we're going to leave it alone. How about this one here? Which of the following square numbers, so these are square numbers, is 24 between? 24. 24 is between what two square numbers? Let's think about this. 24 is between, let's see, it's between, well, 16 is a square number, right? 16 is a square number, and 25 is a square number. And guess what? 24 is in between those two square numbers. Is 24 a square number? No, it's not a square number, but it's between some square numbers. There they are. Which of the following square numbers, well, which square numbers is 52 between? Same with this one. It should say which square numbers. Which square numbers is 52 between? Well, 52 is not a square number, but it is between two square numbers. It's between, guess what? 49 is a square number. 7 and 7. And what? 64. That's a square number. And 52 is somewhere in between them. Now we move to problem solving. A piece of land is 196 meters squares. Guess what? That's an area. So let's make a plot. We'll make a square piece of land. Does it tell us the land is square? Now it does. Square piece of land. If it doesn't say that, then you don't know if it's a square. We're going to write the area inside. 196 meters squares. How many meters of fencing will you need to surround the land? Draw a picture and show your work. Fences go around, don't they? Don't fences go around the land? They go like this, they go like that. So isn't that the perimeter? Perimeter, I'll just write P. And to get the perimeter, what do you have to do? You have to add up all the sides. Now you can use square roots to get, isn't that what a square root is? The length of a side? So we're going to take the square root of 196. Mr. Malcolm, I forgot what the square root of 196 is. That's no problem. We can find it right here. Find 196. Look up. You get 14, baby. We're going to write 14. Oops, I went too far. I'm going to go back. We're going to write 14 here. And we know it's a square, so all the sides are 14. Because 14 and 14 makes what? 196. We're going to add all the 14s up because that's what fences do. They go all the way around. We're going to go 14 meters plus 14 meters plus 14 plus 14. Some of you are like, Mr. Malcolm, just do 14 times 4. Yeah, you can do that. And that's going to make 56 meters. That's the length of the fence. How about these guys? Find the dimensions of each square using square roots. One quick note, first of all, before this. Some of you, for this last question, might not have done square roots. Some of you might have just wrote 14 over here and proven it by saying, hey, 14 times 14 is 196. But I want you to use square roots. Why? Because I want you to prove to me you understand what square roots means. So you want to show me the symbol for square roots. You want to put the area underneath so I know you understand that. Area goes underneath, and then you're going to prove to me that 14 is the answer, and then write it down around your square. That's the right thing to do, and that's what I want you to do. Now the dimensions, that's pretty simple. That's going to be 4 and 4. This is going to be 9 and 9. And this is going to be what? 14. Oh, no, not 14. 13 and 13. Here's another one, a little bit more advanced. It asks us to use the picture on the left. Oh, here's the left. we have an area of 81. Okay. The picture on the right has an area of 144. Okay, that tells us that. Okay, great. Use your knowledge of square roots to calculate the perimeter of each of the little squares, the little ones, guys, not the whole thing. We want to find the perimeter of just one little baby square. Well, what do we know about... Now, this looks like... Let me fix that up. That looks like a rectangle. Let's make it more square-like. That's better. And I think the same with this one here. Let's square it up. That looks better. Now what we can do, guys, is take the square root. You're going to prove to me you know the square root is the area. So you're going to write the area underneath. You're going to say it's 9. That's the whole side, though, right? Isn't that what 9 means? The whole side? So the little baby side must be 3, 6, 9. And then we're going to find the perimeter. Hey, but it's a square, so we can go 3 all the way around, guys. And you're going to get 3, 6, 9, 12. We add up perimeters, right? So you're going to write perimeter equals 12 meters. For this one, you're going to take the square root of 144. You're going to prove to me that square root is the area. You understand that. And that's going to make 12. But that's the whole side. That's the entire side. So we know that the little baby one has to be what? 3. Again, 3, 6, 9, 12. And then you get 12 for the full thing. And what are we asked here to do? Right. The perimeter of the baby square. The baby one. And they're going to be all 3s and 3s and 3s. And you're going to get 12 meters again. Here, wait. Let's do perimeter equals 3, 6, 9, 12.